So hello everyone, today we'll be solving today's Div.3, which is Codeforces round 1072, Div.3. So let's see the problem A. Right now the largest social experiment in the history of Codeforces is taking place involving n people. They are required to form teams of 2 to 3 people. Is it 2 to 3? Yeah, 2 to 3 people. After which each team chooses one of the two civilizations to participate in the social experiment. The organizers of the social experiment want to know what the possible difference in the number of people in the civilizations could be. Find the minimum possible difference. Okay, minimum possible difference. Each test consists of several test cases. Fine. And you'll be having an integer n. Okay. So what does the problem exactly state? Involving n people, they are required to form teams of 2 to 3 people. After which each team chooses one of the two civilizations to participate in the social experiment. So you can either choose 2 people in your team or 3 people in your team, after which each team chooses one of the two civilizations to participate in the social experiment. What the minimum possible difference in the number of people in the civilizations could be. So let's take it this way. So the test case we have is 2512 and 210 is the output. 2512 and 210 is the output. This is the output, right? So let's say if there are two people, n equal to 2, there are two people with you. So what does that mean? When there are two people with you, one civilization would take two people because it has to take two people, other would be 0. So the minimum difference would be 2. 2 minus 0 is 2. When there are five people, one civilization would take 2, other civilization would take 3. The difference would be 1. When there is a chance of having 12 people, one civilization can either have 2 and other can have all the 10, or else 3, 9, and it can also have, it can have 2 to 3 people, right? Let's read the question again. Required to form teams of 2 to 3 people. Okay, a team can join a civilization. 2 people team joins one civilization, rest 10 joins another civilization. 3 people team joins one civilization, 9 joins some other civilization. So somehow we need to be like uh, forming as many as we can. Okay, we need to be forming as many as we can. Like we need to be forming the median. We need to be forming the median. Then only we can get the minimum distribution, right? All these cases till we reach the median will not be getting the minimum difference. So let's say we pair all the two multiples of two possessing teams. Okay, so 12. How to do this? So there are two teams. Okay, wait. I found a logic. I found a logic. What is it? If you have, let's say, an even number, 6 would go to this team, 6 would go to this team. Otherwise, what would happen? 12 by, let's say there are 13 people, 13 by 2 is still equal to 6, and 13 minus 6 is 7. So one team would get 7, one team would get 6. This is what would happen. So if the number is odd, see, understand the problem carefully. It's all about a greedy thing. Okay. So what does it say? Simply, because when it's a large number, let's say 12, you can have multiple combinations, right? You can have 2, 10, 3, 9, and next a multiple of 4 and 8. Then you can have 5 and 7, and so on. But which would give you the minimum difference? Which would give you the minimum difference? The minimum difference can only be attained if you divide them equally. Let's say 12 by 2, 6, 6. In this case, you get the minimum difference, which is equal to 0. Okay. But in case of odd numbers, if n is odd, n by 2 would be some number. Let's say n dash, and n minus n dash would be going to other team and n dash would be coming to one team. All right, so the minimum difference would be always 1 in case of odd. In case of 13, 13 by 2 is 6. So 7 would be going to one team, 6 would be going to one team, difference would be 1. So we found the general case. So let's take this problem. So we have here, we'll write the boilerplate first, then we'll copy it. Okay, this would be the boilerplate. Let's copy it in some, let's say template.cpp. Okay, whenever we need the boilerplate, we'll copy it from here. Fine. So we'll be taking input of n. If your n is, let's say, 2, in that case, uh, it would be just 2, right? 2 minus 0. 2 minus 0 and endl. And else if it's n equal to 3, in that case it would be equal to C out 3 minus 0. One team would get all the 3 members, other team would get 0 members. So yeah, 3 minus 0. Else you got two cases. If n is odd, in that case the difference would be 1. Otherwise the difference would be 0. Fine, that's it. Let's see if this works or not. Taking time to work. And yeah, it passed. Let's submit this. Okay, got accepted. Fine, let's move to the next question. What does this problem state? There's a hourglass, measures s minutes. He flipped it over and the time started. Every k minutes, this guy would flip his hourglass again. I'm unable to pronounce his name, by the way. He will do this even if the sand is still falling. Also, if the sand has already finished falling, but there's still some minutes left, he'll wait for the required time and then only flip the hourglass. Each flip is done instantly. However, Vadim needs to leave for errands in m minutes, and he will stop flipping the hourglass. If Vadim needs to flip the hourglass in the last minute, he will do so. Fine. Determine how many minutes the sand will continue to fall after Vadim leaves. Nice. The wordings are a bit tough. So, okay, there's a guy named Vadim, maybe, who has an hourglass which measures s minutes. He flipped it over and the time started. Fine. So the hourglass sand is falling. It would fall till s minutes. Every k minutes, Vadim will flip his hourglass again. Even if the sand falls or it doesn't completely, Vadim would flip it in k minutes. He will do this even if the sand is still falling. Fine. Also, if the sand has already finished falling, but there's still some minutes left. If sand has already finished falling, okay, sand has already finished falling, uh, and let's say, so what's happening exactly here? There's a hourglass. There's a hourglass which Vadim is there's there's this bad drawing of hourglass which has some sand in it. Okay, it has some cases. One case is if the sand is if sand still has to fall. There's some sand here which still has to fall, and the time has happened k minutes. K minutes are completed. So Vadim would flip the hourglass. He would flip the hourglass. This case is clear. Then there's some other case where sand has completely come down and still k minutes didn't happen. There's still some time for the k minutes to happen. In that case, Vadim would wait for k minutes to complete, then only he would flip the hourglass, which is absolutely fine. Wait for the required time, then only flip the hourglass. Each flip is done instantly. However, Vadim needs to leave for errands in m minutes, and he will stop flipping the hourglass. If Vadim needs to flip the hourglass in last minute, he will do so. Determine how many minutes the sand will continue to fall after Vadim leaves. Fine. First, let me take the input and let's think of the problem more. Okay, we made a template, right, by the way. Yeah. So there's some int S, the total capacity of hourglass, the total time it can measure. There are some minutes K, there are some minutes M. Fine. This is what the input was. And we'll take the input. Fine. So this line here. However, Vadim needs to leave for errands in M minutes. So till M minutes, he'll be able to flip the glass. He'll be able to flip that hourglass. That means total number of flips he can make is, let's say, some n number of flips. The total number of flips he can make is m by k, right? Fine. Is that m by k? In m minutes, he can make every k minute he makes a flip. So the total number of flips would be m by k. If there are let's say 60 minutes, and he can make some every flip in 30 minutes. That means in 60 minutes he can make two flips, which is absolutely fine. So number of flips we have calculated. All right, fine. Now, uh, if after you need to be like calculating the sand after last flip, right? Sand after last flip. Whatever the sand is remaining on the top part of the hourglass, which is remaining at the top part of the hourglass, how much it is. We need to find that. So let's take a variable sand. Okay. So let's take a variable sand and let's say he makes some even number of flips. What would happen if this guy makes some even number of flips? So if this guy makes some even number of flips, he would do a already some sand must have been fallen down. Initially, the configuration of hourglass is this. The initial configuration of hourglass is this. There's sand till here, let's say. Initially, whatever the sand is at top starts falling. After k minutes, the k minutes of sand would fall. That means it would be a minus k. It would be a minus k. Then he after k again he flips, so it would be plus k. So if there's even number of these things, k and minus k would cancel out. Once again, the sand will go back here. Sand cannot go back. Basically, what am I trying to say? If there are even number of flips, k minutes of sand falls down, and once again when he flips, k amount of sand, k minutes of sand again comes back to the top. So this is what is expected to happen. So if there's a k, the sand at the top would be equal to s. Am I right? See, there's some s amount of sand initially, or else let me draw it very clearly once again. There's some hourglass. Okay, there's some hourglass which has s amount of sand at the top, zero amount of sand at the bottom. Next, what happened? Once again, this hourglass, s minus k after k minutes, s minus k was at the top and k was at the bottom. K was at the bottom. Then, after next k minutes, we flip the hourglass. We flip the hourglass, which makes this happen. Okay, which makes this happen. Once again, you have some s here, k here. So first flip, this is the first flip. So this is the first flip, and this is the next one would be the second flip. By the second flip, we'll be having s here and 0 here once again, the previous configuration. So if there are even number of flips, we'll be retaining the previous configuration, the first configuration. That means s would be at the top, so it would take s minutes. So it would take s minutes. And if there are odd number of flips, what would happen? If there are odd number of flips, what would happen? Okay, if there are odd number of flips, what would happen? Uh, either s would stay, either s would stay at the uh, bottom and k would stay at the top. That can happen. Basically, whichever is the minimum that would stay at the top, right? Basically, whichever is the minimum that would stay at the top. If there's odd number of flips case, let me explain. Let's say this is the hourglass. There's s here, 0 here, initial configuration. After k, this would be equal to either s minus k, and this would be equal to k. So once this happens, we'll flip. When we flip, here it would be k, and here it would be s minus k. Fine. So once again, when we flip this once again, here it would be uh, this time k minutes has passed. This whole k has come down. S would be here, and this would be 0. Once again, k minutes has passed. So this would be equal to, by the k minutes, this would be equal to s minus k and k. So this would be a continuous chain that would be happening. So let's write the same logic here. You have variable sand, and if number of flips is, let's say, number of flips is odd, in that case, it would be equal to number of flips is odd. What would be the sand that would be at the top? And k could be greater than s also. K could be greater than s also. So there's no guarantee that every time this would be a positive number. In that case, already this sand might have been fallen down. So we'll consider minimum of s comma k. Whichever is the minimum, we need to consider it, right? So if n is odd, we'll be doing sand equal to minimum of s and k. Otherwise, we will be doing sand equal to s. And what's the time left? What's the time left? If the total number of flips is m by k, the time left would be like the time since the last flip would be equal to let's call it t by m. Time would be equal to m modulo k, the remaining time. So you'll be doing, let's say there are some t minutes. Where is it? Okay, wait. Let's say let's keep a shorter variable name. Once you attain this configuration, once you attain this configuration, that there's some, let's take the or even case because it's easy. So m minutes, some time would be remaining, right? Out of this m minutes, we can do k flips, which is m by k. After doing the last flip also, there would be some part of the m minutes that would be remaining, which we can get by m modulo k. So this m modulo k part of sand, m modulo k amount of sand would be falling down. So all you need to do is uh, int answer would be equal to uh, sand minus t, and let's do max of, either it could be 0 if all the sand falls down, otherwise it could be answer. And yeah, that's it. We'll be doing endl here, should be 0 LL. So let's run this, and it passed. Let's submit this. And yeah, I accepted also. Let's move to the next question. Andre has a huge pile of n apples. He can divide the pile into two smaller piles. If there are x apples in the pile, he'll get x by 2 and x by 2 apples. The division takes Andre 1 minute. Andre wants to eat k apples, but he doesn't want to count them at all. That is why he wants to obtain a pile that contains exactly k apples. Okay, determine whether it is possible to achieve this by performing pile divisions. If it is possible, find the minimum possible time for Andre to obtain a pile exactly with k apples. Okay, How can we do this? This means the largest integer x by 2. This means the smallest integer greater than or equal to x by 2. What does that mean? Largest integer less than or equal to x by 2. So let's say x by 2 is 6.5. Largest integer less than or equal to 6.5 is 6. And smallest integer greater than or equal to 6.5 would be 7. Okay, so that's how the division takes place. Fine. And we need to actually figure this out, how to do it. So how to do this? We need to compute the minimum time. So wait, let me think of it. Hmm. So let's take the input first, and then c1 int k, c in k. All right. So can I say that? Can I say that this n whatever is there, what does n denote? Huge pile of n apples. Okay, we need to, let's solve this problem later. Okay, let's solve this problem later. Let's go back to problems. It's hard to form an intuition upon this. Let's move to problem D. Okay, so unfair game. So this problem says Bob is tired of losing to Alice, and to ensure he doesn't lose again, decided to choose a game in which he is guaranteed to win. Bob has thought of a number from 1 to n where it is known that n equal to 2 power d for some non-negative integer d. Initially, Alice knows whether the chosen number is even or not. Okay, so this guy chose a number from 1 to n where n is 2 power d for some non-negative integer d. Alice knows whether the chosen number is even or not. In one move, Alice can either half the number or subtract 1. Alice can either half the number or subtract 1. If the current number is even, if okay, Alice can half the number if the current number is even. Okay, only Alice takes turns. After her move, Alice receives a response from Bob, either -1, which means the number has become 0, and Alice has 1, or a non-negative integer x if we denote the current number as a non-negative integer x. If we denote the current number as a, then the following conditions hold simultaneously. A is divisible by 2 power x, a is not divisible by 2 power x plus 1. For example, a equal to 5, x equal to 0. Since 5 is divisible by 2 power 0 and not divisible by 2 power 1, and if a equal to 12, it's divisible by x equal to 2, which is 2 power 2, which is equal to 4, and 2 power 5, sorry, 2 power 3, 8. It is not divisible. Fine. So how can we do this problem. Mm, okay, so okay, fine. You can do this, I guess. Let's take the values int n, int k, c in n, c in k. Okay, now what are our observations? Observations. Let's write down observations. Observations are n is a power of 2. N is a power of 2, and d is the set bit position of n. This is what we can say, right? If it's a power of 2, there would be a set bit. Okay, let's write all the powers of 2. What are they? One thing is 1, 2 power 0. There's only one set bit. When there's a power of 2, there's only one set bit. All right, this is 1, 2, 0, 1, 0, 4, 1, 0, 0, 8, 1, 0, 0, 0, and 16. No, wait, no, is it 16? 2 power 4, yeah, 16, 1, 0, 0, 0, 0, and so on. So we need to find the set bit. How can we find this set bit? We can do initially d equal to 0. If n is greater than 0, d equal to, we can use standard STL function, or else there are easy methods to find the set bits. Just iterate and do left shifts. I'm using the STL function. Anything is fine. Okay, and we got two cases. Case 1 would be if my a equal to n. That's what is mentioned, right? If my a equal to n, where is it? Alice knows whether the number chosen is even or not. In one move, Alice can either subtract 1. Alice can only half number if the number is even. Only Alice takes turns. After her move, Alice receives a response from Bob either -1, which means okay, uh, or a non-negative integer. If we denote current number as a, okay, let's say a equal to n. Case 1. In that case, what would happen? In that case, we can do something like, if d plus 1 is greater than k, okay, if d plus 1 is greater than k, then do answer plus plus. Why are we doing this? When a is equal to n, f of n becomes position of MSB of MSB d plus, what's the pop count? Pop count would be equal to 1. So it's equal to d plus 1. If your k, what is k? K is where's the definition of k? Okay, k is the number of moves. If d plus 1 is greater than k, there's you can do answer plus plus. And you have another case, which is case 2. What does case 2 say? If you take a number which is between 1 and n, basically not equal to n. Okay, in that case, what do? We group we would group numbers by their highest bit position. Okay, we would group numbers by their highest bit position. How are we going to do this? Int m equal to 0, m is less than d, and m plus plus, and okay, so m plus plus, and let's take some, we have already defined stuff, right? Let's take lower bound equal to max of k minus n. Fine. If there's a number between 1 to n, which is basically not equal to n, you would consider the lower bound, which is 0 to where is this m? Yeah, m, and m would be like the highest bit position. Okay, we group the numbers by their highest bit position, and this lower bound will be using to group it. So if lower bound is less than or equal to m, in that case you can do for int I equal to lower bound I less than or equal to m and I plus plus answer plus equal to combination of m comma j. Okay, we'll be computing the combination later, but for now this would be this would be the basic answer, right? And you need to see out this not m answer. Fine. So you need to find number of combinations of basically mcj or mci. Okay, so this is what you'll be doing. Now we need to pre-compute the combinations. How to pre-compute the combinations? We can do a simple Pascal's triangle. I hope you know Pascal's triangle code. Constraints. So it's 10 power 4 at max. So it won't go more than, let's say, some 70, I guess. 70 I plus plus. Okay, so C of ij equal to C of I minus 1 j minus 1 plus C of I minus 1 j. This is the basic Pascal's triangle code. If you already know, it's good. Otherwise, I don't think it's a some sort of code that determines you're a good programmer. The basic logic is important. Like you need to apply this to compute the combinations. So let's see if this works. Okay, I guess we messed up somewhere. Missed a semicolon, it seems. Don't we have a variable answer? Don't we have a variable answer somewhere? Okay, we haven't declared answer yet. Yeah, built in. Oh yeah, and we forgot to add the pre-compute here before the test cases. Let's call this pre-compute. Yeah, passes finally. Let's submit this. D. Hopefully it should get accepted. It's a Div.3 man, and I'm a candidate master, so done. Move to the next problem. So we call an array of numbers k exquisite if it has at least two elements and any two adjacent numbers differ by at least k. You are given a permutation p of length n. For each k from 1 to n minus 1, find the number of k exquisite subarrays. Fine. Seems pretty doable. How can we do this? We can, okay, let's think of it. Let's think of it in this way. First, let's take input. Why to waste time unnecessarily? So you have this, okay, wait, template. You will be having n p of a vector named p, and you need to use the input for this. Okay, so n should like what can I say? The array should have at least two elements, right? The array should at least have two elements. If there's only, let's say, if there's only one element, if there's only one element, then you cannot actually make difference out of it. Then you cannot say it's k exquisite. So if n equal to 1, just return. Can't do anything about it. Okay, did they mention it's always? So yeah, this thing is useless. Fine. It was already given in the constraint, so yeah. So okay, and we'll be doing absolute difference for everything. For int I equal to 0, I less than n minus 1. And let's take a difference array. Call it d of size n minus 1. So this would be equal, d of I would be equal to absolute of p of I minus p of I plus 1. So till here, what all we have done, because we need to actually measure the difference to find its k exquisite subarrays, we need to be doing absolute difference of both of these. So we have done it, absolute difference. Now let's think how to actually find the subarrays. Find the subarrays. So vector int, let's take a left and a right. Hmm. How about using a monotonic stack? How about using a monotonic stack? Okay. Uh, let's iterate over this. And while the stack is not empty, and if this is the case, all you need to do is s dot pop. Okay. Stack top should always be the minimum. We are maintaining a minimum stack. So if d of I is less than or equal to this thing, you'll be doing a pop operation. And if you find a d of I that makes the whole stack empty, if you find a d of I that makes the whole stack empty, then you'll be doing 0. Otherwise, if it doesn't make the whole stack empty, you'll be doing s top plus 1. Okay, the basic monotonic stack algorithm. This extra part is belonging to the problem. If it completely empties the stack, then you have nothing to do, right? What are we exactly trying to do? Let me explain. Once we have created the difference, we need to find the we need to use the monotonic stack to find range where di is minimum. We need to find the range where di is minimum. If it completely pops the stack, if it completely pops the stack, That means what does that mean? The left bound of it is 0. Let's say this is some a0, a1, a2, a3, so on. And let's say there are a few more elements till an, and you pick some ai. So if this is the minimum till here, if it's inserted into stack, it would pop a3, a2, a1, a0. That means what's the left bound of the range where ai is minimum? ai is minimum from 0 to some r. Till some r, ai is the minimum. So we'll fit ai as the minimum of this range. We'll fit the ai as minimum of this range. Clear? So ai is the minimum of 0. Otherwise, it's the minimum of till where it was able to pop. Till wherever it was able to pop. Till that range, it's the minimum. Okay? I hope this is clear. Next, we are basically finding nearest smaller element to left. You can also say that. And once you find nearest smaller element to left, which we are doing here, let me comment it. Nearest smaller element to left. Also find nearest smaller element to right. Okay. How to do this? For int I equal to m minus 1, I greater than or equal to 0. These all of them are some sort of lead code problems combined together. Okay. It's a pretty doable question if you have done enough lead code. Weirdly, I guess I would receive hate upon this, but yeah, this is totally based on lead code. I guess whoever the problem setter is, he's a lead coder for sure. D of I. Okay. Tell me one thing. Why did we take greater than or equal to here, and why did we take it's strictly greater than here? Because we need to avoid recounting, right? We need to avoid recounting, or else we would be getting the same range again and again. Yeah. So s dot pop, and if s becomes empty, empty, what does that mean? That means the right bound of this is m minus 1. Otherwise, it's s dot top minus 1. Simple monotonic stack algorithm. If you don't know where to study this monotonic stack algorithm, let's do just monotonic stack CP algorithms. This is a good resource. Minimum stack, minimum queue, you can study all this here. Uh, okay, so this is where you can study. Also, I guess there's a GFG blog here. This is also fine. I have studied from CP algorithms personally. So yeah. So you have nearest smaller element to right. To avoid recounting, you have done this strictly greater thing. Now, all you need to do is you need to find you need to find or you can compute the number of subarrays with a minimum number. Let's say the minimum number is k. Okay, let's say there's a minimum number k. Let's say there's a minimum number k. I hope this works. I am not sure. Let's say there's a minimum number k, and you need to find number of intervals which have the minimum number. Okay, k is already taken. Let's call it something else. Let's call it v. Minimum uh, minimum as v. So if you calculate this using a count vector and count n plus 1 0 maybe, yeah, for int I equal to 0, I less than m, I plus plus, count of d of I plus equal to okay, the start is I, end is L of I plus 1 multiplied by R of I is the start and plus 1. I hope this is contribution technique here. If you know this, you can solve this problem. It's basically like uh, this would denote the number of starts, this would denote the number of ends, and the whole thing multiplied would give you the total number of intervals. All right, this would give you the total number of intervals. Fine. And yeah, originally, if you want to find the contribution of a number, contribution of a number in um, in all the subarrays, let's say it's equal to that number. The number would occur basically I plus 1 into n minus I times. Okay, so this is what it is. Fine. Now, what are we asked? We are asked to compute number of k exquisite subarrays. So this basically would give you the number of subarrays which has v as maximum or d of I as maximum. Okay, so our next idea would be uh, we can do something like compute suffix sums to get answer of k. All right, we need to compute suffix sums to get answer of k. So let's take vector int answer n plus 1 comma 0. Let's take int current equal to 0 for int k equal to n minus 1, k greater than or equal to 1, and k minus minus. Okay, current plus equal to count of k, basic suffix sum, answer of k equal to current, and what you need to do, you need to like output the k exquisite subarrays for all k from 1 to n minus 1. Okay, so k starts from 1, k equal to 1, and k goes till n minus 1, and k plus plus. We just need to print this answer k. If it's the last one, we need not print anything, otherwise we would be printing a space and just to see out and then that's it. Did we miss something? L was not declared. L and R are not declared, I guess. Okay, we named it left and right. Let's run it again. M was not declared in the scope. So what were we thinking about M? Where does the first occurrence of M come? Comes here, right? So M equal to n minus 1. Wow. And we have no received output. Concerning. So it's 6631, but nothing is getting printed. It is not supposed to print this. Let's debug this code. So we are taking the input of n, we are taking the input of array m equal to n minus 1 vector int d m minus 1. Okay, vector int dm. Why dm minus 1? It should be dm, right? Fine. Some betterment. We can simply write it as m and I plus plus di equal to absolute of pi minus pi plus 1. Then we declared this. You can write it in a single line. That would help. It's a single line of code. So you have this vector int L and R and stack int S. Then we applied monotonic stack algorithm, which is for int I equal to 0, I guess then I plus plus. While, okay, S empty. If S is empty, then 0. Otherwise, S dot plus 1. Fine. S dot push I. Then while. Okay, wait a minute. After you do this, there might be some elements remaining in the stack and you need to pop them, right? You need to make the stack empty before actually calculating it for the right bound. While not stack empty, pop the stack until it becomes empty. Fine, this is a bug. This could potentially be a bug. And m minus 1, I greater than or equal to 0, I minus minus. While stack is not empty and difference of stack top is greater than difference of I, pop, and rest seems fine. Let's run it once again. And yeah, it passed. Let's submit this. Let's visit the remaining problems. F is a problem in cherry tree. Okay, problem is loading. Might be a tree problem, I guess, as the name suggests. Yeah, fine. You are given a rooted tree with n vertices. The vertices of the tree are numbered with integers from 1 to n. The root of the tree is vertex number 1. In each leaf of the tree, there grows one cherry. You want to collect all the cherries, and to do this, you perform the following action several times. You choose any of the vertex of the tree V, including the root or a leaf, shake it. After that, cherries fall from all the leaves that are descendants of vertex V. If vertex V is a leaf, then a cherry falls from it. Okay. If vertex V is a leaf node, there will be a cherry to it and it would fall. Otherwise, if you shake the parent, the cherries of all the leaf nodes would fall. And yeah, that's how it should be. If cherries have already fallen from a tree before, the tree will break. So such a situation must be avoided. Okay, so you cannot basically recount something like that. It would be, according to the ancient legend of the cherry orchard, the number of vertices you shake should be a multiple of 3. So it should be a multiple of 3. Is it possible to collect all cherries in this way without breaking the tree? So if the tree breaks, it would be considered a pruning case or a invalid case. And if it's not a multiple of 3, the number of vertices is not a multiple of 3, then it would be a pruning case. Fine. So how to do this? Maybe we can apply recursion. That's the only way I feel we can do it. We should be applying recursion. We should be basically applying some sort of divide and conquer technique, because that's the only way. We need to explore all the possibilities. We need to shake almost every parent. So I don't think there's a greedy way of doing this. We need to be applying recursion. And when you shake a parent and you shake its parent, like parent's parent, you find an overlapping subproblem, right? So I guess we can apply DP. Guess we can apply. I'm not sure. I guess we can. It's a Div.3 who asks DP on trees. Like seriously, DP on trees in Div.3. So we need to have a custom state for DP. So it could either be, if it's like mod 3 we are storing, we need to be storing the reminder, right? The reminder would be an array of size 3. Let's make a constructor for this DP state. Val of 0 equal to val of 1 equal to val of, did I name it reminder? So reminder of 0 equal to reminder of 1 equal to reminder of 2 equal to false. Fine. So now we need to like what's the basic intuition of this is, uh, you need to merge the problems, right? You need to merge the problems. Okay. So what are we asked to find? You need to be checking if there's a way or not. So if there are two subtrees whose possible mod value counts are same. Okay, merge possible mod 3 counts from two different subtrees. Basically, that's what we'll be doing. So let's write a merge function. What would this do? This would be merging the possible mod 3 counts. Okay, let's think of it this way. This would return a DP state again. Basic divide and conquer kind of merge thing. So const DP state ampersand const DP state. To merge two DP states, what you'll be doing? You'll be doing something like, you'll be having a resultant DP state. If A has a true, A gives a reminder at val of I, and J gives a reminder. Sorry, B gives a reminder at val of J. J plus plus. If B gives a reminder at val of J, in that case, result dot val, the resultant val would be equal to I plus J mod 3, which is basic maths. Its parent, like two subtrees parent would give the mod value at I plus J mod 3 equal to true. Let's do equal to true. Fine. And return resultant DP state after merging, whatever the resultant would be. What was the number here? 2 into 10 power 5. So it's mm, 2 into 10 power 5, which is equal to, are there 5 zeros? So let's take some extra space, not a matter. Let's call it something better. DP state F and now all you need to do is a simple tree traversal, I guess, isn't it? We'll be doing a simple tree traversal. Let's take avoid DFS with current node and its parent. Okay. if the neighbor itself is the parent, then continue, and leaf equal to false, because if it's a leaf, it won't have any children, and in that case we need to reach till the children, and result equal to merge of result comma f of v, merge everything simply, and equal to dp state. This is not a beginner friendly problem, I guess, for div.3 especially, because first thing, beginners don't learn these techniques usually. Nowadays people are being weird. I didn't know the basics of T traversals till I was some 1300 rated or something. If it's a leaf, fu dot val1 equal to true, else. Okay. Now you got two options. Okay, now you got two options from here. Okay, let's summarize till here whatever we have done. Okay, we are doing a DFS traversal. Initially, we are assuming that we are at a leaf node, and we are taking a resultant parent, which we can basically shake to get all the cherries. Possibly, we are not sure we can do it or not yet. And result of val equal to true, we are assuming everything is on our side. Like, it's a leaf node, we have a resultant parent which we can shake to get all the cherries, and result dot val equal to 0. That means it leaves a reminder 0 when divided with 3. That would mean basically it's a multiple of 3. So everything is on our side, we assume it, and then we try to do this contradiction kind of stuff. Okay, we try to traverse the neighbors of the current node. If it has neighbors, or necessarily, since it's a tree not a graph, the neighbors are basically the children. If it has some children, it's not a leaf node, so leaf equal to false. And however, we need to find the children because children have cherries. Okay, children have cherries, so yeah, we need to continue the DFS traversal till we reach the leaf node. Fine. Now, and whatever happens in between the path, we need to merge it. So till here it's very clear. And f of fu equal to dp state, a constructor. Initially we are taking a constructor, so it would give you a structure for fu. And if you are at if let's say this loop doesn't work out, that means you're actually at leaf node. Whatever you thought, whatever you assumed was real. Okay, finally you reach the leaf node. Okay, in that case, fu equal to fu dot val1 equal to true, because there's only one leaf node which you have come up with. But okay, otherwise, if you haven't been to a leaf node, you got two options. What are the two options? Option one, you can sum the counts. You can sum the counts of from partitions, right? You can sum the counts from partitions of children, whatever children. Okay. Option two is that shake this vertex, count as one. Count as one means count this as the first shake. Okay, count this as the first shake. According to the legend, number of vertices you shake should be a multiple of 3. That means fu dot val1 equal to 2. You are doing a single shake. And otherwise count the partitions. That means fu equal to result. Continue this process. So let's take int and seeing them. Let's clear the adjacency list first, and let's make the adjacency list. Push back V, and adjacency of v dot pushback u, then do dfs of 1 comma 0. As the question suggests, the root node is 1 and root node has no parent, so it's 0. Now you need to do something like check if a partition with total vertices k equal to 0 mod k exists. You need to check for this partition. How can you check for this? If f1 dot val of 0, in that case, from f1 there's a partition which has a mod 3 0. That means it's divisible by 3. Otherwise, there's no such partition. All right. Are we doing C in for U and V? Yeah, should be working, but did I name it val all over? Okay, let's change it here, whatever. V dot pushback. What's the problem with this? Mm. So I guess this should be a vector of vector rather. Yeah, should it be a vector of vector in? Let's run this again. adj of I dot clear. Clear should be a function, I guess. Hmm. N was not declared in this scope. dp state merge. N was not declared in this scope. Where is this? Where are we calling dfs? dfs of n comma u. But it should be dfs of v comma u. So one error should vanish away. Merge execution policy forward iterator. What's wrong with this now? Can't say what exactly is wrong here. I can't read this much amount of code right now because we are recording also. The duration would be like a burden for me. I guess we already crossed some 1 hour or something. Let's check the duration once. Duration is somewhere, yeah, 1 hour is already crossed. And we still have 2 problems left after this. Okay, so there's a missing semicolon. Yeah, done. Let's stop this. We might have written some sort of syntax errors and stuff. Cherry tree. Done. F is accepted. Now let's move to this problem. G. So how to solve this problem? Andre remembered that he has n blocks numbered from 1 to n. On the block with number I, there is initially an integer ai written. Why can't they directly say it's an array? Anyways, he arranged them in a row in increasing order of the numbers. First is the block with number 1, then the block with number 2, and so on. Basically, it's an array. And they wasted a whole paragraph saying that it's an array. For a certain segment of consecutive blocks L to R, so it's a range query, we call an integer D nasty if minimum of al to al plus 1 plus al plus d, so on till al plus d equal to d. Andre is very curious, so he wants to perform q operations of one of two types. Change the number ai written on the ith block to x. Determine the nastiness of segment L to R. Fine. So it's basically a simple segmentary question. See, you give F problem as a DP on trees and then you give a segmentary problem. Why is it so? F problem was much tougher than this one. This is a piece of cake. Fine. Let's copy the template. Where is it? G. Paste the template. Then you have okay. I need to be writing whole segmentary code because I currently don't have a template for it. And constant. I'll write the template faster. I won't explain also because segmentary is a segmentary. Seg tree. Okay, done with the segment tree code. Now let's write the parts where we need to actually query the segment tree. So if we build a segment tree, once again we shouldn't miss the semicolon. Let's close this. With this we have built the segment tree. Now time to query it. If it's a type 1 query, if type equal to 1, then int ix equal to cin ix. One, nix. While low less than or equal to I, int equal to low plus high minus low. I guess querying is also a part of template only. Like most of the queries are very similar. This is a range minimum query kind of thing. Equal to st dot query, st dot query 1 m l plus d. If minimum value equal to d, nastiness equal to 1, and break from here. Else if min value is greater than d, low equal to d plus 1, else high equal to d minus 1. And at the end just do something like cout. For this else block, let's do cout nastiness. Fine. A simpler question compared to the F question. R minus I was not declared. Where did we use R minus I? Low equal to 0. We used it somewhere here, right? Low equal to 0, high equal to R minus I. We didn't declare I, it seems. Where did I come from? Sorry, why did we write I here? Should be R minus L, right? This should be I only. This should be R minus L. Fine. Once again, let's run this. High was not declared in the scope, but okay. So this is the problem. Int high. A was not declared now. So let's make a vector int A. Now this min has a problem. Long return minimum of query of. I guess I should remove this. So in the query, there's a second argument that is missing. So it's okay. What's the second argument? Second argument should be query of to into node start to mid L to R. Void update int node and start intent. What's the problem with this? No matching function call for this thing. Update. So we haven't written the update function, I guess. But we have written the update function here. Takes node start and index value. So it's node start end. Okay, we forgot to mention start here. So what's in the start here in the update function? So it's mid plus one. Yeah, fast. Writing the codes which are in template is a bit hard for me, especially when time is running out. Let's view the remaining problems. Only C is left, I guess. Only C is left. So let's solve this one C problem. That's it. And let's stop the session. So this one C problem, let us solve. Let us check if that previous problem is accepted. Yeah, it's accepted. Problem C. So let's read this problem once again. What does it say? And it has a huge pile of an apples. He can divide the pile into two smaller ones. He can divide it into two smaller piles. If there are X apples in the pile, he can divide it into, let's say there are 13 apples, he can divide them into 16 and 16, sorry, 6 and 7. So that's how it works. So each division takes 1 minute. Andre wants to eat k apples, but he doesn't want to count them at all. Okay. Determine whether it is possible to achieve this by performing pile divisions. If it's not possible, if it is possible, find the minimum possible time for Andre to obtain a pile with exactly k apples. So if it's not possible, we need to return -1, okay? So that was the problem. Is there a particular way to solve it? So first thing, you'll be given two integers n and k. We have already done c in n and c in k. He wants to eat k apples and you need to determine whether it is possible to split them into smaller pies. Fine. So let's try it this way. I'm not sure it would be right or not. K is greater than n. There's no way you can do it. Keyboard error. Return and just return from here. Next. Int current min would be equal to n. int current max would be equal to also n. Let's take some int time, which is initially 0. Time, let's say, is initially 0. While current max is greater than or equal to k. Okay, why are we considering only max? Because we only need to check until the largest possible pile becomes smaller than k. Okay, if the largest possible pile becomes smaller than k, uh, we need to exit this loop. Okay, and let's say if either of the two possible sizes at this particular level matches k, that means we found the minimum time. If it's exactly equal to k, we have found the minimum time. That means if current min is equal to k, or current max is equal to k, if either of the two values are equal to k, that means we have found the minimum time. So we'll be doing cout time endl and return from here. Next, what if it's not? In that case, we need to divide the current boundaries to get the boundaries for the next minute. Okay, so you'll be doing something like current min equal to current min divided by 2, and current max equal to floor division is by default in C++. For this thing, you should do seal division, which is equal to current max by 2, current max plus 1 by 2, and time plus plus. You will take an extra second because once again you're partitioning. And if current max is equal to 0, in that case you need to break this. That means there's nothing more to left to partition. And if this whole loop fails, doesn't return any value, in that case you'll be doing a return -1. I hope this works and the intuition and approach is clear, I hope. So yeah, passes. So let's submit it for C. Should get accepted. Yeah, done. Whole contest is done. All the questions are done. So I hope all the solutions were clear and the intuition was also clear. We almost took the same time as the original contest. So this was for today. Thank you, everyone. So I hope all of you have a nice day. And that's it. Bye.